You won't even believe this. I tried to do a tutorial on this earlier today, but I ran into a bit of an issue. Here's what happened earlier. All right, let's learn about some... Jeez Louise. Luckily, now I'm okay. Thank you. So, we're going to talk about simplifying some rational expressions. Rational expressions are when you got a polynomial in the numerator and the denominator. It could be a monomial in the numerator and the denominator as well. So it's important that you know things like factoring and how to simplify normal fractions, properties of exponents, all that stuff. It comes into play. So they're also going to talk about excluded values. So remember that you can never divide by 0. So you always need to see what could possibly make the denominator equal 0 and could cause a problem. So we'll figure all that out. So what is the simplified form of x minus 1 over 5x minus 5? State any included values, okay? So first thing we're going to do is we're going to see if we can simplify anything or factor anything. X minus 1, is there any common factor except for 1? No, that's right. 5x minus 5, is there a common factor? Yeah, 5, right? 5 goes into both of those. So we'll keep it x minus 1 in the numerator, but if we factor out a 5 on the bottom, 5 times what gives us 5x? X. And 5 times what would give us this negative 5? That would be the negative 1. Now, how cute is this? X minus 1, x minus 1, what? And they're both grouped off? So you can cancel that out. Phew, phew. Which only leaves us with a 5 on the bottom in the denominator. What's on top though? What is on top? You always got to put something there. So we got to throw a place filler in there. 1/5, that's our final answer. Simplified. But the excluded values part, we got to go to the original equation because there's no variable down there now, so that's fine. But at one point in the original, there is a variable down there. So you take each part that has a variable and you set it equal to 0. If you had x minus 1 equaling 0, then you add your 1 and you get x equals 1. So this is an excluded value. If you substitute in x equals 1 for x, then it would make the denominator 0, and that causes problems, okay? So this is your excluded value. So you say x cannot equal 1. There's kind of two parts to the answer, okay? Oh my goodness. 3x minus 6 in the numerator. Do they have anything in common? U. That's right, 3. So we factor out a 3. We say 3 times x is 3x, and 3 times 2 is 6. All right. The denominator, though. We got all kinds of stuff. We got a trinomial, and we got to factor that. So remember when we're doing these, we got to look at that last number first. They multiply to negative 6. The only way you can multiply to a negative is a positive times a negative with binomials. So x plus something times x minus something. When that last number is minus, they have to be this far apart. They are 1 apart from each other. 3 times 2. Oh, those are 1 apart. So to get them to add up to positive 1, your big number has to get the plus. Your small number gets the minus. 3 times negative 2 gets you negative 6. 3 plus negative 2 gets you that 1 in the middle. Now, do we see anything that can cancel out? Yes. Call me crazy. I mean, don't. I'm not crazy. We should do our excluded values now before we start crossing stuff off. So, look at the denominator. It's fine in the numerator. You can have 0 on top, and that's fine. But the bottom cannot be 0. So, x plus 3 cannot equal 0. So if we subtract the 3, then we know x cannot equal negative 3. Also, x minus 2 cannot equal 0. So you add 2 to both sides, so x cannot equal positive 2. You can't put in 2 or negative 3 into the original equation because that denominator will give you problems. So now let's cross some stuff off. What do you see in common in the numerator and denominator? Boom, x minus 2, x minus 2. So all we have left in the numerator is 3. All we have left in the denominator is x plus 3. If you want to write it with parentheses, go for it. If you don't, that's fine too. In this case, it doesn't matter. So there it is, simplified all the way. And then remember our exclusions from earlier. X cannot equal -3 or +2. Both of those are part of the answer. What's in my eyeball? Ah! Ready to try another one? I knew you would say yes. I knew it. You're so excited. I appreciate that. Oh, this is probably the toughest thing, okay? Let's do the denominator first. 7x minus 14. What do they have in common? Any common factors? Yeah, 7. Okay, so we kick out the 7. 7 times x, 7x, and 7 times -2 is -14. You all know the song. I'm sure you were singing along as well. Here's the deal, though. We have the difference of squares up there. 4 minus x squared. They're both things that you can square root. So the trick for that was you square root them both. You put one with a plus and one with a minus. Okay. Square root of 4, 2. Square root of x squared, x. You knew this. Now, side note, journey with me over here. Is 10 minus 7 the same as 7 minus 10? No. 10 minus 7 is 3, and 7 minus 10 is the opposite. It's -3. So, you can't just flip a thing around when you're dealing with subtraction. However, when you're dealing with addition, 10 plus 7 is the same as 7 plus 10. Those are both fine. So, anytime you want to flip addition, you can do that willy-nilly, no problem. But when you switch out subtraction, like see this says x minus 2, and this says 2 minus x, if you want to flip the subtraction stuff, you can kick out a -1. You can multiply it by -1. So let me show you what that'll look like now. So right here, we're going to take out a -1, and I'll chuck it in front of this one, because I'm a rebel. And then we're able to flip this after that. So as long as you take out a -1, you can flip subtraction. And now if you look, now we have the same thing in the numerator and denominator. They both say x minus 2, so we can unload those. So on top, we have negative parentheses 2 plus x. In the denominator, we have 7. Now, that answer's cool. That's great. Some people will want you to distribute this and make it -2 minus x over 7. That works. And then some people would say, well, put it in standard form and put your x's first. So it would be -x minus 2 over 7. I think that's the cutest answer, but that's just me. And then, again, don't forget the exclusions. Were you forgetting about those? Don't. We can't forget those. We gotta go back to the orig. X minus 2, that's the only variable in the denominator. So let me clear out some room here. By the way, a little hint for you. If it says x minus 2, it's just the opposite. It's positive 2. But let's pretend like we didn't know that. So you'd say x minus 2 does not equal 0. How do I solve that? That's right, you add the 2. So x cannot equal 2. Bit of a light show as well. So there's your exclusion. X cannot equal 2. Here it is in simplest form. -x minus 2 equals 7. Now, let me see, because I see you over there, your eyes are closed. I don't know what's going on over there. Open your eyes. Oh, okay. Calm down. Let's try one more super nasty. Okay, this is the one I wanted. Let me extend the page here. Let's do C. 3 minus 90. What's in common? They both have a 3. Yeah. Kick out 3. 3 times 1 is 3. 3 times 3d gives you that 9d. Remember, factoring is just like the opposite of distribution. If you distribute this, you would get that. On the bottom, a little trickier. We've got a trinomial with a number in front. They call that the a. So usually a is 1 and it's pretty easy. But in this case, we gotta multiply the first and last term. What is 6 times negative 1? Negative 6. If they multiply to a negative, it's gotta be one of each. 1 plus, 1 minus. And they have to be this far apart in the middle. 1. Factors of 6 that are 1 apart, again, are 3 and 2. So it'd have to be plus our big number, 3, minus our small number, 2, which if you recall from our factoring, when we had an a that was different than 1, we had to try to divide that. So 3/6 reduces to 1/2. And then we kicked the 2 to the front. So that'll become 2d plus 1. Same thing here, reduce 2/6, that's 1/3. Kick the 3 to the front. So cleaning it up, ignore these because I'm gonna steal their spot right here. We have 3 parentheses, 1 minus 3d over 2d plus 1 and 3d minus 1. Nice. Look at that. Look at that. They look very similar. They're like close cousins, okay? But they flip the order on the subtraction. All we got to do to fix that is kick out a negative 1. So I'm going to make this 3 negative 3. And then I'm able to flip this 1 minus 3d and make it 3d minus 1. Then in the denominator, I got 2d plus 1 and 3d minus 1. Man, this is a lot of work. I can't believe I'm making you guys do all this. I'm sorry. What can we cancel out from the numerator and denominator now? Yeah. 3d minus 1 for a 3d minus 1. Look at what's left. In the numerator, I got negative 3. Denominator, I got 2d plus 1. If you want to put it in parentheses, go for it. If you don't, then don't. It's our final answer. But don't forget about the exclusions. That's a Katy Perry song, I'm pretty sure. So if you look back to this step, it'll actually make it easier. We had d plus 1 over 2. The nice thing is you could just say that, remember it's like the opposite. If you see plus 1/2, then it cannot be negative 1/2. So d cannot equal negative 1/2. This one said d minus 1/3, so d could not be positive 1/3. These are your exclusions. The other way you could get that is you set each part of the denominator. 2d plus 1 cannot equal 0, and 3d minus 1 cannot equal 0. And you solve both of those, and you would get the same answers. It's just, we can get them way faster this way, okay? So, you're gonna need to practice this to get it down. If you just watch this video one time, it's not gonna work. You gotta actually practice to get better at stuff. If I just say, I'm not good at drums, but I watched a video on drumming, but I don't practice, I'm not gonna get any better at drumming. You know what I'm saying? When you get better at math, it's by practicing. Make mistakes, fix your mistakes. Or just don't make mistakes from the get-go, and then you keep practicing the right way. So get at it, bro. Peace.